that in some countries using seawater salt is produced. In some other countries using seawater water is produced. Water is taken, extracted. Method should be different, isn't it? We take seawater, we heat it, salt remains, water evaporates. So this remaining salt is taken. Can you remember the method? Can you remember that method? From seawater, salt taking method was what? Unwanted water is evaporated, so we call it evaporation, vaporization. And salt crystals form, therefore we call it crystallization. Right. So when we heat a mixture like solution and evaporate unwanted things and get what is left, it was called evaporation, vaporization, crystallization. Okay, but crystallization was something else, but crystallization also happens here. Now today the other one. Example, when we heat seawater, water is evaporating. If we collect this water vapor, චේතනට බයි කිව්වේ පොඩ්ඩක් මේ හරි අපි ආපු ලින්ක්ස් ටික යවලා නැහැ මෙයාට අපේ ලින්ක්ස් ටික මේ ඕකේ හරි ඉතින් when we heat say sea water, we heat sea water, water is evaporating. If we can collect this water vapor and if we can cool it, it will turn back into liquid form. We can collect pure water, distilled water. This is called distillation. This is called distillation. Because this outgoing thing is called distillate. Collecting it is called distillation. Got it? So we are going to discuss about that distillation today. So what are we going to do in distillation? Mixture with one or several things which are ready to evaporate is heated. Then one or more things evaporate. We collect vapor and we cool vapor, we turn vapor back to liquid state and we use it. This is called distillation. What do we call this thing coming out? Distillate, distillation. That way from seawater we can separate water. From mineral oils we can separate petrol, diesel, kerosene, LP gas, everything, all the components. Okay. If alcohol got mixed with water, we can separate alcohol, we can separate water also this way. Okay. So this is the principle, this is the basic. So now I am going to show you the instrument, laboratory instrument used to collect this vapor coming out. Right. This is called condenser, but this condenser has a special name. This is the on the way. This is the laboratory equipment used for this cooling process. Right, this is it. What do we call this? Condenser, condenser, condenser. Right. So as it's not very clear, we are going to use this simple diagram to understand what is going on inside it. What is going on inside it. Right. Look at this. This is from your tube. This is from page 22. Look at this. As I told you, we heat our mixture here. Maybe salt water, maybe well water, maybe mud water. Crude oil we can't heat this way. Maybe alcohol mixed water we can heat. Then one or more evaporating components. These are called actually volatile compounds. If something is ready to evaporate, if its boiling point is low, when we heat it boils and evaporates, it is called volatile. V-O-L-A-T-I-L-E. Volatile is not another tile brand like Mac tile, Lanka tiles. No, yeah, volatile, evaporating. So let's call them volatile compounds then, right? So when we heat, volatile compounds evaporate. Vapor has to go through this inner tube in the condenser. Look at that inner tube. Vapor is given in from this end, vapor is going through this inner tube. When water is going through this inner tube, around this inner tube, water is placed. Actually, water is circulated by supplying normal water or cold water from this end, and by taking hot water out from that end, we circulate water. Okay, then this water can absorb heat. Water is outside, vapor is inside. So water can absorb heat from vapor through this glass wall. Then what happens? Vapor's temperature decreases. Then vapor state change to liquid state. Once again we can collect liquid drop by drop from this end. And remember, vapor is given in from that end, liquid is taken out from this end, water or cold water, sometimes cold water, sometimes just water. We take it from tap. We don't take this water from refrigerator, right? If you write cold water, it should be from refrigerator. Ne? Refrigerator heal karla ganna no. No, it's from normal tap. So water in is here, and this upper end is for warm water to go out. You are going to learn in unit 9 that warm water, warm air always want to go up. So warm water won't go down, warm water wants to go up. So cold water is given at this end. Then the advantage is vapor first is going through an area with warm water, little by little cool water, cool water, cool water. This way, when vapor has to go from warm region towards a cold region, vapor can efficiently, effectively condense into liquid. Paper has questioned this. From which end water in, where is water out? What's the reason? So this way, when we give water in and we take water out, vapor can go from warm region towards a cold region. Then condensation is very efficient. Remember, right? Vapor in, water in is there. Liquid out, but water out is here. And what happens if you keep this condenser this way? Anyway, you are unable to do that because we are using a distillation flask. This distillation flask has an arm tube like this. Then you have to connect condenser that way. Say somehow you fix it this way. What happens? Easily vapor will escape out, and little amount will become liquid. That amount again will come and fall back into mixture. Can't collect. So it should be this way. Right. So this is the instrument. What do we call this? LIEBIG. Where? Here. LIEBIG condenser. Liebig condenser, Liebig condenser, whatever. LIEBIG. But L should be capital. Okay. So that's the end of basics of distillation. But there are 3 types: 7.1, 7.2, 7.3. Right. Let's finish the basics and come to 7.1. Right. Is she new? But you got this tube, right? Right. This for you. Anyone else new? But you got this tube, no? At home, ne? Right, send this. We will make a mechanism to issue tubes properly, regularly. Yeah? Abi hadagam vidya. Tube take a hurry to them. Hurry. Okay, right. Simple distillation, fractional distillation, steam distillation. So we ask capital distillation, simple distillation, capital distillation. No, simple, fractional, steam. Right. What is distillation? Don't highlight. Such direct, simple questions won't come in that. But what is distillation? Separation of components by boiling a solution or a mixture and condensing the vapor. This is distillation. Don't highlight, don't learn by heart, don't. Second one, how is vapor distillate condensed into liquid in distillation methods? I described completely. Let's read. Vapor is cooled using Liebig condenser by circulating water around vapor. Vapor is passed through the tube of condenser and cold water is circulated around the tube. Water absorbs heat from vapor, vapor cools and condenses to liquid. This condense is like your pen. This pen has an inner tube, like that this also has an inner tube. What is inside this inner tube? Ink. They are vapor. Around that there is another tube which you can touch, like that there is the outer wall of the condenser. Now what is in between inner tube and outer wall? Air. Here also air. Right? Here you have put nothing, but if you want you can take a small piece of paper, write your name and put into this name. They are like that. We don't put name, we put water to cool it. Right. හරියට මේ වගේ ඇතුලෙන් බටයක් තියෙනවා එළියෙන් තව එකක් තියෙනවා ඒ දෙක අතර ස්පේස් එකක් තියෙනවා. Right. I want you to highlight these words. Name of the condenser you have to highlight. Name of this condenser. Then highlight vapor in, liquid out. Vapor in, liquid out. Then highlight water in, not cold water, water in. Water in. If we write cold water, maybe we have to connect this to refrigerator, as I told you. No, we are just connecting it to a tap like that. And warm water tube is put into the sink and we open the tap. Simple. Okay, water in here, water out, water out. Right. Now, some important facts. Number one, condenser is kept at a little inclination. I described it. So that liquid formed can come out from its lower end and warm water formed from cold water can come out from its upper end. That way you have to keep. Second one, cold water is given in from the lower end, distant end, so that vapor cools efficiently and vapor travels from warm area towards cold area gradually. Right, last one. This laboratory condenser is made up of what? What material? What do you think? It is made up of glass. Why glass? Is glass good? What do you think? No, glass is not that good. It is not strong also. It breaks easily. Other than that, tell me, is glass a good material to pass heat from vapor to water? Can? Glass කියන්නේ හොඳ material එකක්ද? Heat යවන්න. Is glass a conductor? Is glass an insulator? What do you think? Glass is an insulator. So glass is not good to be here. Glass is not good to be here. Why do we use glass then? ඒක තමයි නේද? ඒක තමයි. මාත් ඒක තමයි. Why do you use glass then? We want to see what the hell is going on inside. Okay, we want to see what's happening inside. That's why we use glass. Can we see what's happening inside? No. Why? Vapor we can't see. When we after vapor becoming liquid, then we can see. Therefore, in factories, industries, they use something like copper, aluminium or copper or something. Why? They don't want to see what happens, but they want it to happen well. So it happens well when we use copper. Why? It's a very good conductor and it's durable. Right. So for demonstrations to study we use glass, but usually we use something like copper. Right, that's the last one. Glass is a poor conductor. Therefore heat transfer from vapor to water is low. We can improve this setup by making the Liebig condenser using a good conductor such as copper. Right. And you can see there is a photo of a very simple good conductor that you can make using large copper tube and a small copper tube. We can wind a small tube on large tube and we can pass water from here to this end and vapor from this end to that end. Simple. People making illegal arak, kasippu hadanai, foreng, they use things like this, and that's why they do it near lakes, paddy fields, because they need water for condensation. හරිද? ඔය කසිප්පු එහෙම හදන අය distillation තමයි කරන්නේ. distillation. කසිප්පු නෙවෙයිනේ. කොකා කෝලා හරි. perfect timing. කියද්දිම බෝතලේ ඇරියා. yes sir yeah. perfect timing. හරි. okay 23rd now. 23rd. what is it? 7.1 simple distillation. Then 7.2 capital distillation. Who said yes? Fractional distillation. 7.3 not here. Steam distillation. Now I am going to describe all these three. Hurry. Now I am going to describe all these three together here. Hurry. Take into your head. I am going to describe all these three now. First one is simple distillation. Right. Then listening time. I gave you a few minutes to talk. Then the magadi දැක්ක දේවල් එහෙම මේ පොඩක් කතා කරන්න එපා ඩිස්කස් කරන්න එපා යාළුවොත් එක්ක. දැන් ඇති. හරි? දැන් සයන්ස් ටික ගමු. right. ඔන්න ගන්න. ඇති දැන් ඇති. ඒක ගැන පස්සේ කතා කරමු. හරි. ඒක කිව්වේ කතා කරනවාද? Simple distillation. Simple distillation is used when mixture is with only one volatile component. That means if our mixture is with only one thing to evaporate, that distillation is simple. Why do we call it simple? We don't have to control anything. Only one is going to come. We just heat, that thing will come out. But if there are many things, many volatile things, many things to come out, we have to control them to take one by one out, because this is a separation technique. If they are coming together, there is no separation. Okay. So if there are many volatile things, we have to take one by one them out. For that we have to control conditions, especially temperature. It is called fractional distillation. Several fractions are going to come out. Okay. Now once again, what is simple distillation? When is simple distillation done? Mixture has only one volatile thing. We heat the mixture, that thing comes out. Example, sea water, salt water. When we heat salt water, water can come out, salts can't come out. Why can't salt come? Salts are ionic, boiling points are very high. So when we heat, only water is coming. Simple distillation. So when we get drinking water, distilled water from sea water, distilled water from well water, mud water, river water, any water, simple distillation is done. But if there are several volatile things, they all are going to come out. Then we use what? We use controlling temperature, techniques of controlling temperature, and we take fraction by fraction them out. Fractional distillation. Example, best example, we take crude oil, mineral oil from the ground. We means not Sri Lankan people, we have a big resource but still under investigations. One day they will find it, they will take it out, then the whole world will have finished using fossil fuels. හරි ලෝකේ fossil fuels පාවිච්චි කරන ඉවර වෙච්ච දවසට මොකද හොයාගන්න ඉන්නේ අපේ වටික තාමත් නෑ අවුරුදු ගාන. හරි say crude oil is taken from the ground. This crude oil has various fuels: petrol, diesel, kerosene, LP gas, even tar. You know tar applied for making roads. Tar also is there. Everything is there. It's a mixture. So from this mixture, one by one, components are taken by fractional distillation. Second example now, alcohol got mixed with water, or water got mixed with alcohol. We want to separate. When we heat, water also boils and evaporates, alcohol also. Water also, alcohol also. So we have to control temperature to take water out, alcohol out separately. What is it? Fractional distillation. Only two examples. Hurry. Last one is steam distillation. In steam distillation, to heat the mixture, we don't use direct flames. We use steam. Using steam, we can heat things evenly, equally, nicely. An example. Tell me which one has more quality, nice outer surface out of normal rotis and string hoppers, or normal hoppers and string hoppers. I didn't ask what do you like. I didn't ask what you like. I asked which one surface is better in quality out of hoppers and string hoppers. Don't say I have never seen string hoppers. String hoppers, ne? Surely string hoppers, ne? Yeah. Why? When we make hoppers or rotis, directly surface is touching the vessel and getting heat. Therefore, outer surface gets overheated, overcooked, damaged also, destroyed also. Middle parts sometimes less heated, not heated enough, sometimes not cooked even. Amui. This thing happening when we are taking essential oils from plants. If we don't use a steam, so we use a steam. Right, let's get to the point. A steam distillation now. Steam distillation is done only when we are taking valuable medicinal compounds from plants. Some plants have them in leaves, roots, fruits, flowers, bark, many places. A steam. If we want to take this out, we use a steam distillation. What do? We cut plant parts into very small pieces and we put into a vessel and we pass heat. Like in making string hoppers, we pass heat through these plant parts. What happens? Heat can evenly, perfectly heat all the plant parts to their boiling point. If we use direct heating, it is said that some plant parts and their essential oils get destroyed because of overheating. Some get converted to other compounds because of overheating. Some don't come out from plant parts. Why? Because of no enough heating. See? Right? Can't heat evenly, can't supply heat equally. So we use a steam. It is said that a steam can heat them all to required temperature without destroying compounds, without converting to other forms. Right? If you want to get jasmine oil, you can put jasmine flowers into a vessel, you can pass heat through it, jasmine oil will evaporate. With water vapor, you can collect. Jasmine oil, water vapor mixture, you can take out. That's steam distillation. Okay. So, what is this steam distillation? We produce heat, we produce a steam, we pass a steam through plant parts. Then plant parts get heated, essential oils present in them evaporate with water vapor. We collect and we cool. We get essential oils and water mixture. But essential oils are immiscible and different in density. Sometimes less dense than water, sometimes denser than water. Therefore, they form two layers. Sometimes oil up, water down, sometimes the other way. Water down, oil up. Or oil up, water down, oil up. Sometimes water is up, oil is down. Okay, we can separate. That's steam distillation. Okay, describe simple distillation, fractional distillation, steam distillation. Quickly, when is steam distillation? When there is only one volatile thing in the mixture. When is fractional distillation? When there are many fractions, when there are many substances volatile in the mixture. When is steam distillation? When we want to extract essential oils from plants. Steam distillation. Right. One by one now. Harida. Basic parts tika hari. Now, with everything, every detail. 7.1 and the setup. Simple distillation. You find your highlighter also. I have printed everything. Washroom and other class එක පටන් ගත්තා විතරයි නේ ඈ ගිලෙන් ටගල් ටගල් හැබැයි තනියෙන් යන්නේ ඈ කොල්ල යන්නේ දෙන්න හරි තනියම යන්නේ Right. පස්සේ ඊළඟ හරියන්නේ දැන් යන්න ගිහලා right. ගිහින් this method is used when mixture has only one volatile component with other non-volatile components. Highlight only one volatile component. Only one volatile component. Only one. එක්කෙනෙක් දෙන්න දෙන්නේ නැහැ. එක්කෙනෙක් girls වල විතරයි දෙන්න යන්න පුළුවන්. ඇයි කියලා අහන්න එපා. හරි. විතරයි දෙන්න යන්න පුළුවන්. Later on, washroom ගිහලා වෙන්න open door there's a ghost. ඒ වගේ situation වෙන්න පුළුවන්. ඒ නිසා ගෑනලම්ට විතරයි දෙන්න දෙන්නේ. අපි ඉතින් බය නැණි ghost කෙනෙක් හිටියොත් පොඩක් පැත්තකට වෙනවා කියලා අපි වැඩේ කරගෙන යනවානේ. හරි. Right. This method, sorry. Hari, only one volatile component, highlight. Right. Inside brackets I have given volatile means what? Low boiling point and evaporates when heated. Right. Third line now. When heated, only volatile component boils and evaporates. It is cooled and condensed to liquid. This method is used in some countries to obtain pure water from seawater. When seawater is heated, only water evaporates. Then water vapor is cooled and condensed. Salts do not evaporate as their boiling points are very high. This method does not need a special control of conditions such as temperature. Why? Only one is going to come, no need to control. Therefore, called simple distillation. So, if they ask why do we call it simple distillation? We don't have to control conditions. Technique is simple, right? They won't ask why do we call it simple distillation. They will ask what is the method used for this? What is the method suitable for that? Oh my! Uses of simple distillation. You have to highlight. You have to remember both examples. On my put one star or highlight. To get pure water from seawater, to get pure water from well water. They will give you example and will ask you to name the method. Okay. Harida. Now set up. Look at this one. Very first thing is I want you to put one red star here. Please draw the setup once, practice. Draw and practice once. Already paper has asked students to draw labeled diagram of the setup. Already has come. හරිද? මේ වෙද්දිත් කියලා දෙනවා setup එකේ අඳලා parts ටික නම් කරන්න කියලා. හරි. Put one red star. As a homework, you draw this and practice. Right. When you draw this stand also, otherwise this will fall down. Draw stand also. Right. This is called what? This is the tripod actually. What is given by this arrow? Make a hill current. What is meant by this arrow? Supplying heat. Heating. You can keep Bunsen burner here, spirit lamp here. You can heat this. Right. What is inside? Well water or sea water. It is a mixture. For simple distillation, we usually use well water or sea water. Right. When we heat this, water boils, water evaporates, and water has only one way to go. It is towards this condenser tube. While coming, water cools vapor and vapor becomes liquid. We can get liquid water, distilled water. Now you can understand the meaning of distilled water. What is distilled water then? Water made by distillation. Simple. Water made by distillation is called distilled water. As we have made it use in distillation, it is pure, 100% pure. Why? Only pure water is able to evaporate, not salts. Right. So, distilled water can be taken. This is a condenser, water in, water out. This special flask is called distillation flask. Distillation flask. Do we need a thermometer here? No, we don't. We don't need thermometer. But if there's a thermometer, you can use this for fractional distillation also. With this thermometer, we can check the temperature, and by controlling temperature, we can do fractional distillation with thermometer. Thermometer here is not essential, Right. That's the end of simple distillation. What are the two examples? Getting distilled water from sea water, getting distilled water from well water, mud water, lake water, pond water, whatever. Right. Now fractional distillation, completely describe, quickly read and highlight. Fractional distillation. Fractional distillation is, will this come? No, they won't ask that question. Fractional distillation is method of separation of several volatile components from a mixture using a fractionating column by distillation under controlled conditions. Highlight several volatile components. Several volatile components. Volatile means evaporating easily. Right. Okay, then highlight under controlled conditions. Under controlled conditions. Okay, second one, conditions required for fractional distillation are. Can you read with blanks and think what to write? What are the words fitting there? Last year wrote everything, this year I printed some, giving you time to think what others are. කාවිගිනන් ගියෝයනේ දෙන්න චුට්ටක් එකෝ ගිය හරි ඔයනේ හරි හිතන්න මොනවද හරින වචන හලෝ ඊයේ මතක් වුණා හරි හිතුණාද වචන components of mixture should be present. No, absent. No, present, absent. No. Should be good. Should be bad. No. Give me the word. Should be. Why not again? Should be. Starting with V. Volatile. Should be volatile. Right there. Volatile. Components of mixture should be volatile. Otherwise, we are heating, not evaporating. We have to use another separation technique then. Ne? Should be volatile. Second one, B of components should be blank considerably. Considerably? සැලකිය යුතු විදිහට මොනවද වෙන්න ඕනලු? What is it? Starting with B also. B of components. What? Banana of components. The word volatile is going with boiling point. So, boiling point should be considerably different so that we can take them separately. Hurry. Right. Boiling points. Right. Boiling points of component should be blank considerably, different considerably. Different considerably. Otherwise, we can't take them separately. They all come together. They all boil together and come together. Right. How does it occur? Ready? How does it occur? Okay, let me describe this one, then we read. Right. I gave you two examples. What was the best? Crude oil. What is the other one? Separating alcohol when mixed with water. Let's take that one now. Right. Alcohol, ethyl alcohol, boils at about 78 degrees Celsius. Water, 100. Therefore, when alcohol and water are together, if we can heat the mixture to 78 alcohol starts to boil and evaporate. Boil. Water without boiling, little amount will evaporate. Water boils at 100, no, but alcohol boils at 78. So when we heat this mixture to 78, alcohol starts to boil. Bubbles same hadila, forming bubbles. Alcohol evaporate rapidly. Water also can evaporate at 78. You know what is evaporating from our skin even now? Set water. What's the temperature here? 78? No. Less than 37. Less than 37. Inside the body 37. Surface can be slightly less than 37. Ne? Right. But what is evaporating? So alcohol will come about 96%. Water will come about 4% when we maintain temperature at 78. So we can separate alcohol. But little water is coming. Can't stop. If we can take that mixture, distillate again and again, we can get alcohol percentage higher. By second distillation, third distillation, fourth distillation, we can get highly concentrated alcohol. That's what we are going to read now. How does it occur? When we heat mixture to the boiling point of one component, it boils and evaporates greatly. Other components evaporate slightly. When we cool vapor, we get a higher percentage of more volatile component and low percentage of other components in liquid form. Example, boiling point of ethyl alcohol is 78 degrees Celsius and water 100. When we heat an ethyl alcohol solution to 78, alcohol evaporates highly and water evaporates slightly. When we cool it, we get a solution where alcohol percentage is very high and water percentage is very low. We can distillate this mixture again and again to increase alcohol percentage more and more. So we met our first example, what is separating alcohol when mixed with water. Fractional distillation number 1. Then we have number 2. Before that, what is the setup? Where is the setup used for this one? This one? No. There was the setup. Chocolate. Chocolate the ganne hori. I come on, I want to kala panay to illa. What is the setup used for this? Actually, setup used for this is the same. This one. I told you this thermometer is not necessary for simple distillation. With thermometer, we can do what? Fractional distillation with alcohol and water. So let's write after all finally with a star. The setup above is used for this. Right at the end of page 23, the setup above, is used for this also. The setup above is used for this also. The setup above is used for this also. The setup above is used for this also. Hari. මම කිව්වා මේ වෙද්දි ඇවිත් තියෙනවා setup එක අඳින්න කියලා. මොකක්ද අඳින්නේ? දැන් ඔබ කිව්වා මොකක් අඳින්නද දන්නේ නැහැ නේ. You know, you have put one red star there near the setup. That's the setup. Okay. So I thought no point of printing same setup twice. Yeah. So I didn't print. Right. Then තමයි වැඩේ. Second one. Page number 24. ගිහින් බලන්න. Very complicated. Neither? What is this? Fractionating tower. Or we can call this fractionating column also, fractionating tower. Then it's little difficult to understand this. So we just have a look, make a balala. I'm going to show you an animation. But after watching animation, you can't sleep. Animations bala nida gannawa watte. Okay, look at this page number 24th main diagram. This tall structure is called fractionating tower. Neither වැඩිය බලන්න එපා මම කියන ටික විතරක් බලන්න. This is called fractionating tower. Into this fractionating tower, we supply crude oil after heating. We heat crude oil and supply into this. And how much is the temperature here? We don't know exactly, but this part is like 250 Celsius. You don't have to remember temperatures. Top part is like 25. So temperature at the bottom is high, temperature at the top is low. Notice that one. That means temperature is decreasing. When temperature is decreasing, what happens? Try to understand this one. Okay. Say temperature here is 300. Assume that. මේ පැත්ත පොඩ්ඩක් බලන්න. එයා දිහාම බලන් ඉන්නකෝ. එයා දිහාම බලන් ඉන්නකෝ. මේ පැත්ත පොඩ්ඩක් බලන්න. හරි. 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 මේ පැත්ත පොඩ්ඩක් බලන්න. එයා වැරදියට තේරුම් ගන්න එපා. එයාගේ පිරිනමය දිහා බලන් හිටියේ. පිරිනමය දිහා බලන් හිටියේ. එයා දිහා ඒක ඊට වැඩි අවුල්ද? ෆ්‍රෙන්ඩ්ෂිප් එකට බලන් හිටියා. මේ පොඩ්ඩක් බලන්න ඕනේ. මේගොල්ලෝ හිතා මේ පැත්ත බැලුවා කියලා. නෑ. මේ පැත්ත බැලුවේ නෑ මම දැක්කම හොඳට. වැඩිම මේ පැත්ත බලන්නේ. අපි බලන් ඉන්නේ අහගෙන අනිත් පැත්ත බලන් ඉන්නේ. Hurry. Okay, look at this. Say temperature here is 300. If temperature is 300 here, tell me this Inca oil which has boiling point 250 is a liquid here, solid here or a gas here? Hitanda, say temperature here is 300. When temperature of crude oil is 300 here, is this Inca oil? Lubricating oil which have 250 boiling point is in which state? Boiling point 250, temperature is 300. What is the physical state? Gas. Why? They all boil at their boiling points. So when it is 300 here, all these are in which state? Gaseous state. Harida, me okkama at 300, LP gas is a gas. Petrol will be a gas, naphtha, kerosene, diesel, lubricating oil, Inca oil, all will be gases. Then they start to rise up. Can you see? These are some gates. There are some openings. Through these openings, they go up and they want to go up. Why? They are in gaseous state. But here on the way, we are maintaining decreasing temperature gradient. So, say Inca oil, its boiling point is 250. Say temperature here is 200. When it is coming from 300 to 200, at 300 it was a gas. At 200 is it a gas now? No, it is a liquid now. Why? Its boiling point is 250. So when it is coming from 300, 290, 280, 70, 60, 250, now it has to become what? Liquid. Then it comes out from this one. This way, when we decrease temperature at the right place, right level, gas becomes liquid, and as liquid they come out. Finally, LP gas is coming out as gas because its boiling point is 25. Right. So here temperature is very high. All these are what? Gases. While going up, as temperature is decreasing, one by one, gas turns to liquid and comes out. Inca oil comes out, lubricating oil comes out, diesel, kerosene, naphtha, petrol, finally LP gas. So we are maintaining what? Temperatures. We are controlling what here? Temperatures. When we control temperatures, gas mixture has to turn into liquid state. So this is distillation. Why? What is distillation? Distillation means liquid crude oil is turned to vapor. Yeah, vapor here. And again we cool and condense into liquid. Now I am going to show you an animation for this. Using that, I think you can understand much better. Hurry. Till animation is coming, මං සරයක් සිංහලෙන් කියන animation එක ගෙනගන්න. අපි ගොඩක් රත් කරපු crude oil මේකට දානවා. එතකොට වාෂ්ප විදිහට තියෙන්නේ උඩහට යන ගමන් temperature අඩු වෙනකොට එකින් එක liquid වෙවි එළියට එනවා. Right. ඔන්න fractional distillation animation. This way, as I told you, vaporized components want to rise up. While rising up, some of them become liquid and start to come out. Neither. When they came to their boiling point, thereafter they can't be gas anymore because in the next level temperature is low. And while going up like this, after coming to boiling point, when cooled little further, it becomes liquid and it starts to come out. Okay, hope could understand. Right, I am going to stop somewhere and I am going to describe one last time. Right, because if you memorize, you can answer only limited questions, but if you understood the process, you can answer any creative question. හරිද? කටපාඩම් කරොත් සීමිත උත්තර ටිකක් විතරයි ලියන්න පුළුවන්. තේරුම් ගත්තොත් අහන ඕන එකට පුළුවන්. right මෙහෙමයි. Heated crude oil is given into this. At this high temperature, it is a mixture is mostly a gas. But you can see one turn to liquid and we are taking it out. Others are gases. After coming to this one component, change to liquid state. What is it? Diesel. Okay. Diesel's boiling point is present here. Diesel's boiling point is absent here. So when it is coming from present area to absent area, gas has to turn to liquid. Diesel comes. So here boiling points of all these are available. So they are gases. They come to this level. And this level, at this level, kerosene can't find its boiling point. Here present, here absent. Then kerosene turns to liquid and comes out. Harida. Here in this part, boiling point of naphtha, petrol, gases available. So they are still in gaseous state. At this level, naphtha cools below its boiling point and turns to liquid, coming out. This way, petrol, gas finally comes out as a gas. Okay, fractional distillation. So you can understand here we are maintaining some conditions. What? Especially temperature, maybe pressure also. Therefore, separately we can take them out. Right, page number 24, fractionating tower. This diagram, should we remember all these components and boiling points? Can you remember all? Can, but difficult. Then don't try to remember all. If your memory is extraordinary, then remember. We have to describe only once. අපෝ එහෙම වුණුත් ඉන්නවද කියලා ඔකේ බැලුවා. හරි. එහෙම ඉන්නවා සමහර වෙයි. එක සැරේ කියන්න ඕන මතකයි. ඊළඟ දවසේ මම වැරදිට කිව්වොත් ටක් ගාලා කියනවා සර් එදා කිව්වේ ඔහොම නෙවෙයි කියලා. එහෙමයි තියෙනවා. හරි. ඕකේ. එහෙම ඉන්නවනම් ලේසි අත්තර වැරදිච්ච එකම අපිට කියනවා ටක් ගාලා. මේ So don't try to remember everything then, but you have to remember at least one from the topmost level. What is it? LP gas, petroleum gases. Take your highlighter, highlight petroleum gas. Top petroleum gas coming. Give me one material coming from middle part. What do you feel? කවුද හොඳම එක්කෙනා මැද හරියෙන් එළියට එන? Diesel. I said something wrong. මැද හරියෙන් එළියට එන කියලා මොනවා හරි වැරදියක් කිව්වද නෑනේ? I mean in this fractionating column something coming out from middle part. What's the best? Diesel. Highlight diesel. Diesel. What is from the bottom? You can highlight this bitumen tar or even Inca oil. කැමති එක. Did you get my message? Message is, if you can remember all these, you remember. If not, you try to manage your question by memorizing one coming from top, one from middle, one from bottom at least. හරිද? එහෙම හරි ඕනේ. උඩින්ම එන එක්කෙනෙක්, මැද හරියෙන් එන එක්කෙනෙක්, පල්ලෙහින් එන එක්කෙනෙක්වත් ඕනේ. Right? Okay. Boiling points, no need to remember. But you must know top part's temperature is the lowest, middle part medium, bottom is the highest. That also you have to know. Usually we know which kind of questions coming, which area they are going to ask. Okay, right. Then fractionating tower. Crude oil is a mixture of many hydrocarbons. Hydrocarbons contain only hydrogen element and carbon element. That means all these contain hydrogen and carbon. Yes. In this tower means fractionating tower. What's the name of this? Fractionating tower. Highlight the name also. Fractionating tower. In this tower, temperature is controlled at different levels, at different values. Therefore, components can be withdrawn at respective levels separately. Temperatures of its upper levels are low. Therefore, components with lower boiling points such as petroleum gases are extracted from upper levels. Okay, highlight. Temperature of upper levels are low. Temperatures of upper levels are low. Okay, found it? It's in the 1, 2, 3, 4th set, 4th paragraph. Paragraphs nanne, 4th one. Hurry. Then last one. Temperatures of its lower levels are high. Let's highlight that also. Lower levels high. Lower levels high. Right. Therefore, components with higher boiling points such as Inca oil are extracted from lower levels. Right. Why are they? Extra knowledge part. This extra knowledge part is important. So we remember. But this extra knowledge has a diagram. No, this diagram you don't need. Take your pen, cut and remove extra knowledge parts diagram only. Diagram එක විතරක් අයින් කරන්න. Extra knowledge කියන එකේ තියෙන diagram එක විතරක් අයින් කරන්න. මෙයාව මේ only this one in yesterday class several students had cut this also. No, not this one. This is you need. Cut this. Now listen carefully. I am going to describe this story. A-level results came ne. ඔගොල්ලෝගේ අයියලා අක්කලා අපිත් ඉස්සරහව සමහරු results එවලා දිනනවා. ඉස්සර ක්ලාස් වලට පොය රිසල්ට්ස් අහම මතක් කරලා ඒවල තියෙනවා. හරි? Okay. This is the story. Fractional distillation first example was alcohol water mixture separation. Divorcing alcohol from water. Second one was fractionating tower, getting various fuels from crude oil. Third one is, we need oxygen for respiration of patients, various factories, divers, mountaineers, astronauts, they need oxygen. Oxygen can be produced by many methods according to grade 10 unit 16. Heating potassium permanganate, potassium chlorate, many methods are there. Even electrolysis can be done, but the cheapest method to get large scale oxygen, large amount of oxygen, cheapest is fractional distillation of atmospheric air, because our atmospheric air has about 21% oxygen. If we can separate, it's very cheap. Right. So, how to separate oxygen from atmosphere? Fractional distillation. Just listen, these are the steps. Atmospheric air is filtered to remove dust and unwanted things. Then we pressurize and cool. When we cool it to about 78 Celsius, carbon dioxide becomes directly solid. What is it? Dry ice, grade 10. We remove it. We cool the mixture further. When we cool it to up to about minus 200, everything becomes a liquid. It is called liquid air, liquefied air. Our atmospheric air becomes a liquid. That means water. Yeah, water නෙවෙයි. එහෙනම් you know things have solid state, liquid state, gaseous state. Our atmospheric gases are in gaseous state. When we cool, they turn to liquid state. So we can get something like water at minus 200, liquid air. This liquid air which is at minus 200 is little by little heated. We don't have to heat, neither. They are getting heated, ne? We have to cool actually them. When we allow them to come to minus 196, nitrogen's boiling point comes, nitrogen liquid bubbles and comes out as pure nitrogen gas. We can collect it. When we increase temperature to minus 183, oxygen's boiling point comes, pure oxygen gas bubbles. Bubbles form in the liquid and starts to come out. We can collect. That way, nitrogen, oxygen can be separated from atmospheric air by fractional distillation. Okay, so it's important, not extra knowledge actually, but this diagram is extra. But that knowledge is helpful. So, look at this diagram. You have cut and removed this. Ne? I බලන්නවත් එපා. දැන් විතරයි බලන්නේ. We take air and we compress air. Air heats up as it is compressed. And we have to cool now. By sending liquid nitrogen, we cool this air and we put into this tank. The compressed air is cooled. Compressed air is allowed to expand and turn to liquid, and then we put into this at minus 200. Inside this fractionating tower, we maintain 185 minus 190 minus, we can get nitrogen and oxygen. Setup is not necessary, cut and remove setup, but leave this part. මේ part එක තියන්න. අපි read කරමු ඒක. Fractional distillation is also used to separate components in atmospheric air. When air is pressurized and cooled to about minus 200, it liquefies. This liquid is a mixture of several components. They vaporize at their boiling points. Nitrogen boils off at minus 196 Celsius, whereas O2 and CO2 at minus 183 degrees Celsius and minus 78.5 degrees Celsius respectively. පොඩි idea එකක් තියාගන්න. ඔහොමයි අපි oxygen gas ගොඩාක් හදාගන්නේ. නැතුව lab එකේ ඇස්සේ රත් කර නෙවෙයි අනම්මන. Right, finally, uses of fractional distillation. I want you to put one star. Star එකක් ඕනමයි. Told you examples you have to remember. ඕනමයි examples. Right. Uses of fractional distillation. Number 1, to extract several fuels from crude oil. You can highlight fuels from crude oil. Highlight fuels from crude oil. Number 2, to separate alcohol from water. Highlight alcohol from water. Don't misunderstand. Don't think that we can get alcohol from water. බාගෙට අහන් ඉන්න අයට එහෙම ඇහෙන්නේ ඈ. Alcohol from water හදන්න ඕනද ගෙදර ගිහිල්ලා. You can't do that. You can't get alcohol from water if alcohol got mixed with water. Then you can separate. Thank you. Today we learn how to get alcohol from water. Fractional distillation. If alcohol got mixed with water, we can separate. Hurry. To separate alcohol from water, you can write when mixed. When mixed. Alcohol can be taken from water. When mixed. To separate alcohol from water when mixed. Third one, to extract nitrogen and oxygen from atmospheric air. Right. Now the last, steam distillation. Describe everything, ne? Told you. To get valuable medicinal compounds from plants, especially in Ayurvedic medicine, perfume industry, beauty culture karna, right? We need this one, right? And I told you why steam. Now directly some photos. Look at this. Getting various components from crude oil using fractionating tower. Is there any such factory in our country? Fractional distillation towers තියනවාද? නෙළුම් කුළුණ නෑ ඒක නෙළුම් lotus tower. Anyone in our country? Yes? No? Yes, there's one. Where? Sapu gas කන්ද සපු ගස් කන්ද සපු ගසුත් නැහැ කන්දකුත් නැහැ සපු ගස් කන්ද හරි සපු ගස් කන්ද තෙල් පිරි පහදුව සපු ගස් කන්ද there's a purification plant. So we import crude oil from other countries and in our country we separate all these fuels. It's good. Rather than importing petrol separately, diesel separately, kerosene separately, we import crude oil. It is cheap and all these fractions can be produced here locally. Right. Some other fractionating towers. Simple distillation. Put one red star for this diagram. Draw it and practice at least once. Right? Practice this. Can ask you to draw. Let's try to understand. Water is taken, water is heated. Why? To get steam. Steam is passed through this delivery tube upwards through plant parts to boil plant parts, to boil essential oils. Essential oils in plant parts boil. To prevent cooling, we heat this also. Essential oil and water vapor, steam, both enter this and get condensed while going through this, and we get a mixture of water and essential oil. Sometimes water is down, sometimes water is up also, told you. Right. This is a steam distillation laboratory setup. Maybe you have to draw this and name all the parts here. මේක පොඩ්ඩක් බලන්න හරි. පොඩ්ඩක් බලන්න හරි. මේ නෑ මේ දිමුතු ඔයාට නෙවෙයි කිව්වේ ඔයත් ඔළුව වෙන ඔයාට නෙවෙයි ඉස්සරහින් ගෑල් ළමයි ටිකට කිව්වේ ඒගොල්ලෝ දිහාම බල බල ඉන්නවා මේ පැත්ත බලන්නෙම නෑ ඒකයි හරි ඕකේ right හරි heating water delivery tube once again heating, otherwise this water vapor steam will become water here, so we have to heat this also. Cinnamon leaves we use inside this. Anything can be used, jasmine flowers, rose flowers, anything. This is the condenser, water out from that end, water in from this end, we get water and oil mixture, but you know they are immiscible, so we can get two separate layers. This is laboratory setup. Shall we see a real one? This is a real one. Where are plant parts? In which one? Home plan. Arakya tulai. Kila plan kara. Where is plant parts? According to the shape of this, you can understand that we are collecting oil in this and plant part should be inside this. This can be the steam generator. There are some pressure measuring pressure gauges also. This can be the boiler. This can be the boiler. You know, if steam pressure increased highly, these boilers blast and people die, workers die. Therefore, pressure gauges are there. Steam is very dangerous. Right. Okay. Right. Not chromatography. We are here now. Highlighter ready? Right. I told you, why don't we heat directly? What are the disadvantages? Why do we heat using a steam? What are the advantages? Everything described, printed here. We highlight. Okay. Steam distillation. This is a method used to extract volatile compounds present in plants. such as cinnamon, clove, citronella, nutmeg, cardamom, etc. What is the best plant material for you to name? If you have to name, exam day, cinnamon leaves. Why? Our O-level setup is with cinnamon leaves. Best is cinnamon leaves. So you can forget all others, but don't forget cinnamon. Plants have volatile compounds mixed with water inside cells. These volatile compounds are mostly immiscible with water. Their boiling points are greater than that of water. Stop. How much is the boiling point of water? 100 degrees Celsius. What can you say about the boiling points of essential oils in plants? Less than 100 or 100 or greater than 100? Greater than 100. There is a point here. If you want to boil water, we have to heat up to 100. If you want to boil essential oils, we have to heat beyond 100. But something nice happening here. It is said that when essential oils are mixed with water in plants, we can evaporate both, we can boil both at a temperature below 100. When water is alone, 100. When essential oil alone, greater than 100. When mixed together, less than 100, below 100. So, below 100 Celsius, we can boil essential oils. If they ask in the exam, which of the following are correct about steam distillation? One statement. Boiling point of water is 100 degrees Celsius, so we have to heat plant parts to 100. Correct, but wrong. Water 100, correct. We don't have to heat up to 100, wrong. Then they can say, boiling point of essential oils is greater than 100, therefore we have to heat greater than 100, beyond 100. Correct and wrong. Palavani bhagi hari, iduru bhagi varadi. Hari, they would say, boiling point of essential oils is greater than 100, but we have to heat below 100. That one is correct. Unbelievable, but that one is correct. Okay, now we are reading that. Right. Their boiling points are greater than that of water. These volatile compounds are called essential oils. When these compounds are together with water, boiling point of mixture drops below the boiling point of water. Can boil easily. Can boil easily. Hari, ekat already ganda. Heat is supplied to volatile compounds through steam. Why? Direct heating cannot increase their temperature uniformly. If you have to write the disadvantages of direct heating, you can write this. Cannot increase temperature uniformly. If we heat them directly, some of the compounds get destroyed and some get converted to other compounds. You know, when we fry an egg, most of the nutrients get destroyed. Do you know that? Yeah. What's the best way of consuming eggs if you can? Raw, amuing. But don't try to do mandang kala tinolu. Again, Mr. Voddakian Koyogi again. Kala the meal at the end. Kanda bonda in raw. Hurry. But don't try. Why? There are very harmful bacteria associated with the shell, egg shell. If you consume them very quickly, you can get diarrhea, loose motion. Right? A bitter katte inno bacteria varga. Unut ekka consume unut ivarai. Loose motion thamai. Hari? Then better you don't try to consume raw. Half boil is the most nutritious way then. Half boil. Then full boil. Finally, frying. Why? Temperature denatures proteins, that's why. Okay, same way, essential oils get damaged, destroyed or converted if we heat directly. So we don't. Right. Steam can increase temperature of volatile compounds up to boiling point uniformly. That's why we do. Okay. Hari. So if they ask why do you use steam here, you can highlight this sentence. Steam can increase temperature of volatile compounds up to boiling point uniformly. Uniformly means in all the plant parts this is happening. Otherwise, in some plant parts happening, some plant parts not. හරි. එහෙනම් අපි line එක highlight කරමු. The line just above the setup. Setup එකත් එක්කම උඩින් තියෙන line එක highlight කරන්න. එහෙමවත් කියලා බලමු. Then don't ask which page හරි. Okay. Page number 25. ඒකත් කිව්වා මොනවා කරයිද දන්නේ. හරි. There's a sentence right above the diagram, highlight it. Okay. Steam can increase temperature of volatile compounds up to boiling point uniformly. That's why we use a steam. But further, exam day you can write direct heating is not done because direct heating damage converts to others. You can write those also. Hurry. Did you put one red star for this diagram? Do it now. Draw this once and practice. At least remember how to name all these parts. මේ ටික නම් කරන්න හරි දැනගන්න. Right the right. Now after setup. When heated through steam, both volatile compounds and water in plant materials evaporate below 100 Celsius. Highlight below 100 Celsius. Vapor mixture is cooled using condenser. Both volatile compounds and water turn into liquid. Volatile compounds and water form two separate layers as they are immiscible and densities are different. So remember, essential oils are immiscible, mixed when and boiling, and densities also are different. Densities also different. Sometimes, as I told you, oil is floating on water, and sometimes water on oil, right? Water on oil also. Right. Then last one, neither. To increase surface area, plant materials are crushed and put. Then evaporation is fast and easy. Surface area is high, boiling evaporation is faster. Essential oils are used as flavors and condiments to produce perfumes, toothpaste, pharmaceuticals. You can highlight all these: condiments, perfumes, toothpaste, pharmaceuticals. Right. Now we are not going to do this paper chromatography because after this laboratory extraction of essential oil, today itself we should talk about industrial production of essential oil. For that we jump over all these two particular pages. See, chromatography next time. Salt production, salton next time. We jump over all these to this one, not page 25. This year's page is 29. Right. Take page 29. Let's finish this and we try to finish solvent extraction also. Monkey, let's do it finally here. Today we started later. I said 250 to 450. 450 okay we other. Next week more again 3 to 5 da 3 to 5. Nema, you will say no 245, but you come here around 3. Ema ba 245 damu kila 3 o'clock end ba 3 to 5 damu මොකද කියන්නේ එම අහන්නේ මේ no one's schools going to end at 1:30 නේ 1:30 කාගේවත් ඉවර වෙන්නේ නැති වෙන්නේ no නේ not possible නේ it should be 2:30 right 2:30 වත් වෙයි නේ එහෙනම් 3 to 5 දාමුද next week අපි 3 to 5 and when I send you message next Sunday night we are going to conduct class from 2:45 to 4:45 you send me you reply me sir are you mad what's wrong with you you said 3 to 5 please remind me හරිද මම 10:45 එන්න කියලා අහන්න සර්ට අමතකයිද පිස්සුද 3 to 5 තියෙන්නේ කියලා මට එවන්න නැත්නම් මටත් ඕක අමතක වෙනවා 3 to 5 දාමු එහෙනම් හරි පුළුවන් නේ 3 with the slowly you can come 3 to 5 මේ කොහොමද ඉතින් 5 විතර නම් කරනවනේ අපි 3 to 5 right page number 29 essential oil extraction but not laboratory method industrial methods there are 3 methods right extraction of essential oils ready essential oils what's the Sinhala name essential oil Sinhala name if you translate word by word essential oil must be අත්‍යවශ්‍ය තෙල් මොනවද අත්‍යවශ්‍ය තෙල් but Sinhala name is not අත්‍යවශ්‍ය තෙල් what's that අත්‍යවශ්‍ය තෙල් no in Sinhala it is called සගන්ධ තෙල් සගන්ධ කියන්නේ සුවඳක් තියෙන aroma there are aromatic compounds in this smelling compounds in this right නේද jasmine oil aromatic සගන්ධ තෙල් සුවඳක් තියෙනවා right essential oil extraction hari what are essential oils volatile compounds obtained from plant materials they have aroma smell therefore they are called aromatic compounds hari right some essential oils produced in Sri Lanka are remember few cinnamon leaf oil in the setup also cinnamon leaves are there cinnamon bark oil citronella pepper cardamom nutmeg clove eucalyptus remember 2 3 but don't forget what cinnamon leaf oil because in the setup cinnamon was there some uses of essential oils are listen under some uses there are 3 no cinnamon bark oil pepper oil cardamom oil for what cinnamon leaf oil pepper oil cardamom for what jasmine oil rose flower oil for what this way we can't remember separately so you remember together some essential oils are used to produce certain things like perfumes for soap pharmaceuticals toothpaste remember that way හරිද මෙයාව මේකට අරයව ඒකට එහෙම නෙවෙයි මතක තියාගන්න මෙන්න මේවට ගන්නවා එතකොට ඇති right cinnamon bark oil pepper oil cardamom oil promote flavor and scent of food next set to produce medicinal ointments toothpaste perfumes for soap last one it's nice so let's read jasmine flower oil rose flower oil to produce perfumes so you can highlight now perfumes for soap toothpaste medicinal ointments highlight කරලා දාන්න. හරි. එහෙම මතක තියාගන්න. මෙන්න මේවට ගන්නවා toothpaste. So can you remember Clove Guard advertisement they are showing clove bud oil you can remember right Lux advertisement they say රෝසමල් දහසක සුවඳ කෙහෙල් මල එක මලකව සුවඳ නැහැ අර බලන්න ලක්ස් කැටයක් කොහොමද රෝසමල් එච්චර සුවඳ නැහැ නේ right table some plant and their parts used in essential oil extraction so once again you should not try to remember this whole table let's highlight few things that we already know like what let's go and find vetiveria savandara we don't know roots are used maybe you don't know then forget it sandalwood stem highlight sandalwood stem next time when TV commercial කොල්ලෝ ටික මේක අහගන්න next time when TV is showing you someone is applying sandalwood look at well not the person no where applying look at which part is applied sandalwood stem අර sandalwood stem එක මෙහෙම අතුල්ලනවා පෙන්නයි ඒක බලන්න මේ sandalwood stem is used can remember right? Highlight sandalwood stem, right? Cinnamon, bark, root, leaf. You can highlight, of course, cinnamon, bark, leaf. Next to don't highlight, citronella leaf, lemon, lime, fruits used. Right hand side, lemongrass leaf is used. You don't know what lemongrass is, ne? There's a plant called lemongrass. Leaves used, don't highlight. Eucalyptus, leaves used, don't highlight. Clove, floral parts used. Yeah, next time when commercial is coming, clove guard or something, you observe will, not toothpaste and brushing teeth, no, clove bud you can see, right? Highlight clove, floral parts. Then jasmine, rose jasmine flower, we know that nutmeg seed is used. What is the single name for nutmeg? And murichi, nutmeg, sadika, right? Nutmeg, right? I think essential oil is what essential oil uses are what you all know. Now we see how to extract essential oils, not in the school laboratory, in factories. In factories. I forgot to tell you, we are talking now about industrial applications of separation techniques. First one salt production, second one this. Okay, now we are talking about industrial applications of separation techniques. Number two, essential oil production. So in factories, one of the three methods are used for essential oil extraction. They are 2.1, 2.2, 2.3. What is 2.1? Extraction of essential oils by steam distillation. Number two, by solvent extraction. Number three, by pressing. That's the simplest one, right? Let's take 2.1. Extraction of essential oils by steam distillation. From that laboratory glass equipment, we come to real factories extraction setup. This also is something which you can get. Using heat of this, we boil water, and through this exhaust gases can go. Even oxygen can come. Exhaust gases can go. Ne? Yes, oxygen can't come because after learning unit 9, you will learn that downward nothing can come here. Heated air always is going to go up, convection currents. So this is to escape exhaust gases. Right. Water is boiled to produce a steam, and this steam is coming through this, and the steam is passed through plant parts which are very small, and then plant parts get heated, essential oils evaporate, water vapor, essential oil vapor, both through this vapor of essential oil and water come to this condenser. This condenser actually is a coiled tube, is a copper or aluminium coiled tube, and water is there around it. When it's a long one, we can pack it as a coil using a small space, right? So nicely condensation occurs, and we get into this cinnamon oil and water mixture because we have used cinnamon leaves. Simple, ne? Very simple, right? So this diagram also can come, but then this laboratory diagram can come. A steam is generated by the steam bath and passed through plant parts. Ready? Focus karamu. Steam is generated by steam bath and passed through plant parts. Essential oils vaporize at a temperature below 100 Celsius. We know that. Condensation of vapors gives essential oil and water. As they are immiscible, mixed when they can be obtained separately. One will be floating on the other one, can be separated. Right, so that's how essential oils are made by steam distillation in factories. Next one, extraction of essential oils by solvent extraction. Let me describe that. Solvent extraction, still we didn't do, we are going to do after this. Taking 15 minutes, we are going to do. Solvent extraction is this. අහන් ඉන්න. ඒක කරලම් මේකට ආව නම් හරිනේ. අමතක වෙයි. මම යන්තම් කියන්නම්. In solvent extraction what we do is we take a solute dissolved in one solvent into another solvent by giving a better solvent. Okay, there is something, a solute dissolved in a solvent. That solvent is bad for it, not very good for it. If we can give a better solvent, we can take solute into that, and then we can evaporate this solvent, we can get the solute. කතාවක් මතක් වුණා කියනවා නම් හිතන්නකෝ මෙහෙම ඔන්න සිංහලෙන් කියනනම් ඈ කාගේ හරි කවුරු හරි එක අෆෙයා එකක් තියෙනවා. දැන් අපිට ඕක බ්‍රේක් කරන්න ඕනේ. අපි බොරුවට වෙන එක්කෙනෙක්ව අර දෙන්නගෙන් එක්කෙනෙක්ව යාළු කරනවා. බොරුවට යාළු කරවන්න. දැන් අරක බ්‍රේක් කරනවා. මේක ඉතින් බ්‍රේක් වෙන්න දෙයක් නැහැ. මේක කොහොමද බොරුනේ? Solvent extraction is like that. හරි? There is a solute in a solvent. We want to separate the solute, but we can't. Why? There is a solvent. We give another solvent to that solute, and solute comes to this one. Then this solvent can be separated. Right? This is solvent extraction. We do it now, but before that we read it. Right? When we apply that technique here, when we apply that technique here, when we apply that technique here, what we do is, you know, plants, some plants have valuable chemical compounds, like say cinnamon oil, where in the cytoplasm, mostly what is it? Water. And cinnamon oil, essential oils don't like water. Therefore, we give a much better solvent to this essential oil, maybe ether, maybe toluene, maybe chloroform. Then essential oils get dissolved in this one. We can take it out. Then we can evaporate this solvent. We can get essential oils. Solvent extraction. Right, let's read. Organic solvents such as ether, chloroform, toluene are used in this method. Plant parts are mixed with solvent and shaken. Then essential oils dissolve in the solvent. Then solvent is evaporated. Right? Say we take a container of ether and we put a plant part into it, and we, like say, shake it well. We try to mix it with solvent. Essential oils come out from plant parts into ether. Now ether has essential oil. We can evaporate ether, we can get essential oil. Okay, solvent extraction. Right. Highlight here what are the solvents used. Ether, toluene, chloroform. Highlight their names but not chemical formulae. Don't highlight chemical formulae, highlight names. And I want to take your pen and cut and remove chemical formulae. There are long chemical formulae. Don't think you want to remember. Cut, cut, cut. All three chemical formulae. Why did I give them? I gave just, if you want, if you like to know, ether has which elements? Is ether has gold or something? You don't know, so I give. Right, last one, extraction of essential oils by pressing. You know, by squeezing, by pressing plants, we can get essential oil out. Essential oils in some plants are extracted by pressing them to a suitable pressure. But it is not that simple. You know, when we press it, what happens? Essential oils come with water. It is said that in these pressing machines there are absorbent filters. When we press, essential oils are absorbed into these filters and then can be taken. You don't need, not in the textbook even, just remember, pressing is one method of essential oil extraction. Solvent extraction is another one method. Steam distillation is another one method. Okay? Right. So essential oil extraction has three methods: solvent extraction, steam distillation, pressing method. Right. Now we go and see what solvent extraction is. After doing that, there are some videos to watch. Then young solvent extraction water. Right. Our solvent extraction on page number 6 is a colorful activity, beautiful activity. As it's very colorful, and we can do in a school lab. This comes usually for O-level paper and term test also. And most probably you are going to get this diagram. Have I printed it? Yes, page number 21. If you have colors, you can color. But if you don't have colors, listen now, go home and color, because it's colorful, it's really nice. This is our textbook diagram now. I am going to show you a real photo of it. What are the colors visible? And colors you can find. Yellowish brown one thing, colorless something. When we mix, pale purple. When we allow it to settle, pale yellowish brown and purple. Right. Look at this. This is a real one. Now listen carefully. This is the story. This is the standard O-level story on solvent extraction. Listen carefully. We have a solution here. That solution is called iodine solution. How can we make iodine solution? By dissolving චුට්ටක් මේක අහගන්න ඕන එකයි. හරි. මේක අහගන්න ඕන. Right. We have a solution. What is this solution? Iodine solution. How to make iodine solution? By dissolving iodine in water. Even though දෙන්නේ කතා කරන්න මම නවත්තනවා කතා කරන්නේ. මේක අහගන්න ඕනේ දැන්. මේක එනවා එක්සෑම් එකට ඒකයි කාටවත් කතා කරන්න දෙන්නේ නැහැ. කතා කරොත් මම නවත්තනවා. හරි. මේ iodine solution is present, but this iodine solution has a small issue. It is iodine doesn't like water and water doesn't like iodine much. Reason? Water is a polar substance, charged substance. Iodine is a non-polar substance. Therefore, iodine is with water, but iodine doesn't like water much and water also doesn't like iodine much. If iodine asks, water, shall I go out from you? You will say, okay, you go if you want to go. Right? So that's the issue in iodine solution. Water is polar, iodine is non-polar. So if we want to separate iodine from iodine solution, what we do is, we mix iodine solution with another solvent. This solvent should be much better for iodine than water. Why was water bad? Water was polar, iodine non-polar. So this new solvent should be a non-polar one. It should be of iodine's type, right? Iodine non-polar, water polar, therefore water is bad. So if we can give another non-polar solvent, carbon tetrachloride, hexane, cyclohexane, thinner, something like that, iodine happily comes into this one, leaving water. Therefore, if you add these two together and if you shake this, giving good contact for iodine to come into CCl4, iodine comes into CCl4. After that, it becomes purple. It becomes purple. You can see it is coming now. It is coming. It becomes purple. So this colorless layer becomes purple, and brownish layer water becomes pale in color, pale brownish in color. So this is the only example, only one example where we mix colorless thing and brownish color thing together and getting purple color solution. හරිද? colorless එක්කෙනකුයි brownish color එක්කෙනයි mix කරාම දම් පාට solution එකකුයි pale brownish එන්නේ මේකෙන් විතරයි. Right. Okay. So this is our activity. Non-polar iodine is with polar water. We give non-polar solvent. Non-polar iodine comes into non-polar solvent, and water gets very little iodine. Solvent extraction. By giving a better solvent, we can extract solute into that. And later you can heat this purple color one, you can evaporate solvent, you can get iodine. This is our solvent extraction example. Example this way now. Men of a standard setup. This instrument has no name in the textbook. This is called separation funnel. There is a tap here. When you open this tap, this colorless layer you can take out Or this purple color layer you can take out and you can separate them, separation funnel. So, into the separation funnel, what are we adding? Iodine solution and CCl4. Take into your head now. Iodine solution and CCl4, carbon tetrachloride, grade 10, unit 10, dot cross diagrams and the CCl4. එයා තමයි ඈ. Oh, iodine solution and hexane. Or cyclohexane, no hexane. Hexane කිව්වත් ඇති. It is colorless. We mix this with iodine solution and we shake it well and we allow them to settle. We can see colorless layer has become purple, iodine has come, brownish layer has become pale in color. Little amount of iodine is this, there, iodine is there. What is given by these arrows? Iodine in this go into that and iodine in that comes into this. Both happening, forward and backward. හරි දැන් මම ඔලුවට යන්න ඇති කියලා හිතනවා. තව පොයින්ට්ස් වගේක් තියෙනවා. There are some facts to be discussed. Right. That's the story, no? That's the diagram. And then other facts. Solvent extraction. So, what we do in solvent extraction? We provide the better solvent for a solute and we take solute out from the first solvent. What is meant by better? Several times I said better solvent, better solvent, better solvent. මොකද්ද මේ better කියලා කිව්වේ? මම ඉතින් ඉගෙන ගන්න ඇති කතා කරන්න. What's the meaning of better? Better solvent කිව්වේ ඇයි? Better solvent කිව්වේ මෙහෙම දෙයක්. Then points වලට යනවා. Solvent extraction needs about 3 factors to do. Solvent extraction needs 3 factors for it. These factors you have to remember. Right. Can you understand that solubility of iodine is low in water and higher in CCl4? Maybe yes, maybe no. Remember, for solvent extraction, we use a new solvent which can dissolve solute much better. In other words, මං හරියටම කිව්වොත් the solvent used by us නෑ අනිකෙන් පටන් ගමු solute එකෙන්. Solubility of the solute should be higher in the new solvent and should be lower in the first solvent. Got it? What's the first factor? Solubility of the solute should be low in the first solvent and higher in the second solvent. පළවෙනි solvent එකේ solubility අඩුයි, දෙවෙනියාගේ solubility වැඩි හොඳට දිය වෙනවා. This one. Second one is two solvents should be in contact with each other. Two solvents should be in contact with each other. That's why we shake it, we mix it. Otherwise, iodine has to jump from this one to that one. No. Iodine should touch it. They should be in contact with each other. Otherwise, solute can't go. And the next thing is, two solvents should be immiscible. First solvent and second solvent should not mix with each other. Otherwise, iodine will get crazy, mad. Why? Where to be? They are mixed together. No, they should be immiscible. Then iodine can decide, okay, I am going with that solvent because my solubility is high there. Right? Now, what are the 3 factors? Solubility of solute should be low in the first solvent, higher in the second solvent. Two solvents should be in contact with each other. Two solvents should be immiscible. And there's one more thing, it's little weak. Densities of solvent should be different. Then one can float on over the other one. Right? There are 4 actually. I have given third one, but it should be the 4th one. I am going to give a better third one now. Right. Let's read and see. Solvent extraction. What is solvent extraction? Will this question come? What is solvent extraction? Don't expect so. So don't highlight, don't learn by heart to get this point. A method of drawing up a substance from a solvent in which it is less soluble into another solvent in which it is more soluble when two solvents are immiscible and in contact with each other. Right? So this definition as factors we are going to write under question number 2. Before that, inside brackets. A solute is dissolved in a solvent slightly. We add another solvent into it which can dissolve the solute more. Then the solute comes out from the first solvent and gets dissolved in the second solvent. Right? Now that's like you have a friend with you, you don't like that friend much and you get a better friend. Okay. So you leave the first friend and you go with that better friend. Okay. Solvent extraction. Number 2 now. Write the conditions required for solvent extraction. Put 1 star. Can come. Conditions. Number 1. Solubility of the solute should be blank in the first solvent. What's the word there? Right. If you were listening, of course you can write it. What's the word? Angirana liyanna bola. Angirana liyanna bola. එහෙම මම අහන් ඉන්නවා කියලා බලන්නේ. හරි. Should be ඔව්. ලියන්න පුළුවන් නම්. Should be LOW low LOW. Right. Solubility of the solute should be low in the first solvent, but it is higher in the second solvent. Second one now. 2 solvents should be immiscible. Then sure කරලියයි අර පේන්නේ නැහැ කියන එක invisible කියලා. Immiscible. How to write immiscible? IMMISCIBLE. Immiscible. Mix වෙන්නේ නැති වෙන්න ඕන. Third one. Actually third one is not third one, it is fourth one. So please change number 3 to 4. Number 3 4 කරන්න ගෙලින්න. 3 උඩම 4 ලියා ගන්න. එතකොට හරි එක number 3 නෙවෙයි ඒක number 4. What is number 4? Of 2 solvents should be different, right? They are densities. Right. Densities of 2 solvents should be different. Right. Then put number 3 and write number 3 now. Number 3. 2 solvents should be in contact with each other. 2 solvents should be in contact with each other. 2 solvents should be in contact with each other. 2 solvents should be in contact with each other. Right? 2 solvents should be in contact with each other. Right. Yeah. Now third one, I want you to take your pencil and cut. Fourth one, sorry. Fourth one, densities, take your pencil and cut. Don't write it. If you have to write 4 only, you write fourth one. Otherwise you write 1 or 2 or 3. Because fourth one is a weak one. You wrote about densities, no? Cut it using your pencil. Don't use it. Unless essential. නැත්තම් when you have to write one factor or සමහර ලියනවා density. ලකුණු නැති වෙන්න පුළුවන්. There are very good 3 more factors and this is the weakest one. Right. Look at the setup now. Is setup clear? Write the laboratory procedure to demonstrate solvent extraction. We will write it on the next page. Setup okay, the separation funnel. Aqueous solution of iodine yellowish brown or brownish. Go home and color it. Carbon tetrachloride or cyclohexane, we can call it hexane also, colorless. While mixing, pale purple. After allowing to settle, dark purple or purple comes and pale yellowish brown top layer is there. And next thing is, remember what is up, what is down. Exam day, you will be thinking, there were 2, iodine solution and hexane. Which one knows up? ඉතින් උඩ බලනවා. උඩ මුකුත් නැහැ. හරි? ඔළුවේ තියාගන්න. According to our textbook setup, what is upper one? Iodine solution. What is lower one? CCl4 hexane. After mixing, what is the upper one? Same pale brownish. What is the lower one? Same, purple. ඒකයි කලර් කරන්න කියන්නේ. ඒතකොට මතක හිරිනවා. උඩින් කොයි පාටද මෙයා කොයි පාටද කියලා. Right. Now after completing this part we have some videos taking, it takes like 5 minutes. Page 22 steps. Number 1. Blank is dissolved in blank. Sorry, blank is dissolved in blank. It forms a blank solution. Niyamai. It forms a blank solution. And then CCl4 is obtained. It is colorless. Ne? It is colorless. Right. Now what's the first one? Blank is dissolved in blank. It forms a blank solution. Hurry. Let's write. Iodine is dissolved in water. Iodine is dissolved in water. Hurry. It forms a. Don't write. It forms iodine solution. Iodine solution है तो it forms a copper sulfate solution है. हरे it forms a it forms a brownish solution. It forms a brownish solution. Yellowish brown නෙවෙයිද brownish කිව්වම ඇති. Brownish solution. CCl4 is obtained. It is colorless. It is colorless. Number 2 now. Blank and blank are added to separation funnel. ඒක නම් දන්නවා. මොනවද add කරන්නේ? iodine solution and CCl4. Now let's write CCl4 and iodine solution. CCl4 and iodine solution are added to separation funnel, mixed well after closing the lid. Mixture is allowed to settle. Water becomes, let's write, pale brownish in color. Pale brownish in color. CCl4 becomes, CCl4 becomes purple. මම නිකන් කියන්න හිතනවා රෙඩ් කියලා. ඒකල බලන් ඉන්න හිතනවා කී දෙනෙක් රෙඩ් කියලා ලියයිද කියලා. හරි. ආයෙ ඕනේ නැහැ නේ මේ බෑඩ් ටයිම් නේ. දැන් මොනවා යුවත් ලියනවා මේ වෙලාවේ. හරි. purple. නිකන් මං ලියුවත් නිකන් CCl4 becomes a dull solution කිව්වත් dull කියලා ලියන්න. Time is like that. CCl4 becomes purple. Purple. Due to dissolving iodine. Due to dissolving iodine. තවත් එකක් තියෙනවා. How would you separate iodine from above solution? Right. We heat it, solvent evaporates, iodine is left. Okay, right? We separate purple color solution. Yes, next take answer. We separate purple color solution and heat. We separate purple color solution and heat. Right, second line, next line. Solvent inside bracket CCl4. Solvent inside bracket CCl4 evaporates. And iodine remains. And iodine remains. Right. Last line. Iodine crystals can be collected. Iodine crystals can be collected. Iodine crystals can be collected. Right. Can you see there's a special statement inside brackets. A small amount of carbon tetrachloride is adequate. Adequate means enough. Now in the video, next video which I am going to show you, you will see to a lot of iodine solution, little amount of thinner is added. Why little amount of thinner or CCl4 is added? Solubility is very high. That little amount is enough to take all the iodine into it. Got it? We don't have to add a lot of thinner or lot of CCl4, little amount is enough. Right. A small amount of carbon tetrachloride is adequate to extract a large amount of iodine from water. As what's the reason? Write the reason. Space is not enough. As solubility of iodine is a blank එකේ අන්තිමට තියෙන පොඩි blank එක. Solubility of iodine is high in CCl4. Solubility of iodine is high in CCl4. It's a poddak tibbahama ඇති. Right, last one, write one common occasion of using solvent extraction. අපෝ අපි දන්නවා one common occasion when medicinal extracts are produced using plants. A solvent such as ethanol is used to extract plant medicinal compounds found only in trace amounts. Highlight medicinal extracts ethanol. Medicinal extracts ethanol. Then choti doubt එකක් එන්න ඕන ඔයාලට. Small doubt should come. Here this says ethanol, but on that page it was ether, toluene, chloroform. Why? Here ethanol, there not ethanol. Why? Here we are talking about medicinal drugs. Like you know, in Ayurvedic medicine, lot of plant medicinal drugs are chemicals are used. And those bottles are called what? Starting with A. Arishta. Arishta bottle තියෙන්නේ නේ. ඔව් නේ. ආයුර්වේදවල. In Arishta bottles, medicinal extracts are there and the solvent is little ethanol. Now, I personally don't use alcohol. Right? Never use. Don't want to use also. But sometimes I say I don't use alcohol. Some people ask, don't you use Arishta? I say, no, Arishta what for? I ask, why? No, if you are using Arishta, people say we don't use alcohol, but they use Arishta. I think Arishta has alcohol. No. Yeah, in medicinal drug extraction, little amount of alcohol is used as the solvent. It is in Arishta. That's why sometimes people using long time, years and years, Ayurvedic medicine Arishta, they get liver problems because of alcohol in Arishta, right? So here medicinal drugs alcohol used, but in that page cinnamon leaves, jasmine, rose, alcohol is not used. Toluene, chloroform, ether can be used. Harida me apita bond khand හදනේ වගේ තමයි ඔය ඇල්කොහොල් ගන්න. අනිත් ඒවායි ගන්න නැහැ. හරිද? අපි කන බොනේවට ඊතර ටොලුයින් ක්ලෝරෝෆෝම් ගත්තොත් මැරිලා යයි. That's why. Right. Now there are very few. So did you highlight here medicinal drugs and ethanol? Yes. There are 3 videos to watch. Watch well. Actually there were 4. Already you have watched 1. Right. Chromatography we don't want නියමයි. මෙයත් ඕනේ නැහැ. Extraction of iodine. Right. Iodine solution brownish in color. Separation funnel. Into separation funnel, according to textbook, first we had CCl4, but now we had iodine water. It doesn't matter. Thinner is used instead of CCl4 hexane. Thinner we can find from hardware. Lab එකෙන් හොරගම් කරන්න ඕනේ hardware එකෙන් thinner ගන්න පුළුවන්. Little amount of thinner is added. That's why thinner is added secondly. චුට්ටක් අහන්නකෝ කෑ ගහන්න බෑ. Little amount of thinner is enough, so we add carefully along the wall little amount of thinner. If you want to see thinner layer, colorless layer separately, carefully you have to add, because after coming thinner into this, iodine gets to know that iodine comes into it. Iodine ආරංචි වෙච්ච ගමන් iodine දිය වෙනවා. ඉතින් පරිස්සමට හොරේන් මෙහෙම දාන්න ඕන. හරි. Now you can see iodine layer, thinner layer. It is not colorless because little iodine has already come. Little amount is enough. Now we are going to contact these solvents very well together. We are going to contact them very well. Pale purple color can be seen like in diagram. pale purple color on a separation funnel. Then we allow it to settle. We get pale brownish color layer and purple layer. Pale brownish one, but purple color can be seen. If you keep long time, it will be without purple color. Right. Iodine has come to this one. Why? Solubility of iodine is high in this, low in that. Right. Next one now. Simple distillation, I think, yes. Laboratory setup for simple distillation. I think they are doing simple distillation there. On a simple distillation setup, you can see mixture is here. This is distillation flask, maybe mud water, and boiling, maybe mud water. We don't need thermometer now. This is condenser. You wanted to see what's going on inside that, but you can't see. Drop by drop, we can get distilled water out. This glass is not an efficient conductor. If we can make this using copper or aluminium, it must be better. This gives you very good idea about being immiscible and solubility. Make a short diagram, story of video balangin. This is water, and then this is not water, this is not water. This is water, this person is adding something else. It would be what? Maybe ether, maybe hexane, maybe thinner, but not water. Now adding, water bottle is missing. Water bottle missing. So second layer is then water. You can see water layer is immiscible with, you stop, I'll describe. Water, and this should be non-polar one. So this is water layer immiscible with this, and this can be once again something like thinner, hexane, ether, not ether, thinner, hexane, CCl4, something like that. Can you see they are immiscible? මෙයානේ water එහෙනම් මේ උඩ එක්කෙනයි යට එක්කෙනයි water එක mix වෙන්නේ නැති non polar දෙන්නෙක් CCl4 වගේ hexane වගේ දෙන්නෙක්. Now going to dissolve iodine, going to pass iodine. You can see iodine dissolves quickly in this. Iodine goes through this one without getting dissolved and dissolves well in this. බලංගින්ද iodine dissolves very well, making it purple. And going to put iodine through water down to the third one. It goes without getting dissolved in water and dissolves in third one. Third QMA, first, second, third. First, water, third. ඔම්බාන දැන් iodine කැටයක් දානවා. අම්බාන වතුර දිය වෙන්නේ නැතුව පල්ලෙහාට ගියා. Solubility is low and now it is getting dissolved. Okay, right. So non-polar iodine and non-polar solvent. Non-polar iodine and non-polar solvent. This is polar water. Now going to mix all these together. What would happen? He is going to put all these 1, 2, 3 into this bottle and going to mix. What happens? 1 and 3 mix together. When upper one and lower one, 1 and 3 mix together. But second one says, no, I am not going to mix with you. I am immiscible. It stays colorless. You can get an idea about what is meant by being immiscible. High solubility, low solubility. See, iodine never stays in water when iodine has a better solvent. Iodine water වලට එන්නෙම නැහැ හොඳ solvent කෙනෙක් ඉද්දි. එහෙනම් ඔය ඇවිත් තියෙන්නේ. Keep watching. Getting separated. Now you can understand that density of water is highest now. Density of the mixture of 1 and 3 lower than that. So what is separating now? Middle layer water has gone down now. 1 and 3 mixed together and density of the mixture is lower than that of water now. You saw that, no? Third one was, the top one was less dense, third one was dense. After mixing them, they become less dense, right? So, iron is here, iron is not here. Little amount of iodine is there, but say iron is not there. Right, the last one. Okay. So, next time we have only chromatography and salt, and that's all. Can finish, ne? Next time can finish.